Detection algorithm usage. When and how often? Oh, sorry, just now we forget this one. Yeah, this one. Okay. This detection algorithm simply investigates every possible allocation sequence for the processes that remain to be completed. Algorithm requires an order. Application is similar as Banker's algorithm. Okay, and so detection algorithm usage. When and how often to invoke detection algorithm depends on how often a deadlock is likely to occur, how many processes will need to be rolled back when deadlock happens. If detection algorithm is invoked arbitrarily, there may be many cycles in the resource graph, and so we would not be able to tell which of many deadlock processes caused the deadlock. And deadlock occurs only when some process makes a request that cannot be granted immediately. This request may be the final request that completes a chain of waiting processes. In the extreme, then, we can invoke the deadlock detection algorithm every time a request for allocation cannot be granted immediately. In this case, we can identify not only the deadlocked site of processes, but also the specific process that caused the deadlock. In reality, each of the deadlock processes is a link in the cycle in the resource graph, so all of them jointly cause the deadlock. If there are many different resource types, one request may create many cycles in the resource graph. Of course, invoking the deadlock detection algorithm for every resource request will incur considerable overhead in computation time. A less expensive alternative is simply to invoke the algorithm at defined intervals. For example, once per hour or whenever CPU utilization drops below 40%. A deadlock eventually cripples system throughout and causes CPU utilization to drop. If the detection algorithm is invoked at arbitrary points in time, the resource graph can contain many cycles. In this case, we generally cannot tell which of the many deadlocked processes